Chapter 19 of the Montessori Method. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Melissa. The Montessori Method by Maria Montessori. Translated by Anne E. George. Chapter 19. Teaching of Numeration. Introduction to Arithmetic. Children of 3 years already know how to count as far as 2 or 3 when they enter our schools. They therefore very easily learn numeration, which consists in counting objects. A dozen different ways may serve toward this end, and daily life presents many opportunities. When the mother says, for instance, "There are 2 buttons missing from your apron," or "We need 3 more plates at table." One of the first means used by me is that of counting with money. I obtain new money, and if it were possible, I should have good reproductions made in cardboard. I have seen such money used in a school for deficients in London. The making of change is a form of numeration so attractive as to hold the attention of the child. I present the 1, 2, and 4 centime pieces, and the children, in this way, learn to count to 10. No form of instruction is more practical than that tending to make children familiar with the coins in common use, and no exercise is more useful than that of making change. It is so closely related to real life that it interests all children immensely. Having taught numeration in this empiric mode, I pass to more methodical exercises, having as didactic material one of the set of blocks already used in the education of the senses, namely the series of 10 rods heretofore used for the teaching of length. The shortest of these rods corresponds to a decimeter, the longest to a meter, while the intervening rods are divided into sections a decimeter in length. The sections are painted alternately red and blue. Some day, when a child has arranged the rods, placing them in order of length, we have him count the red and blue signs, beginning with the smallest piece, that is, 1, 1, 2, 1, 2, 3, etc., always going back to 1 in the counting of each rod, and starting from the side A. We then have him name the single rods from the shortest to the longest, according to the total number of the sections which each contains, touching the rods at the sides B, on which side the stair ascends. This results in the same numeration as when we counted the longest rod, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wishing to know the number of rods, we count them from side A, and the same numeration results, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This correspondence of the 3 sides of the triangle causes the child to verify his knowledge, and as the exercise interests him, he repeats it many times. We now unite to the exercises in numeration the earlier sensory exercises in which the child recognized the long and short rods. Having mixed the rods upon a carpet, the directress selects one, and showing it to the child, has him count the sections, for example, 5. She then asks him to give her the next one in length. He selects it by his eye, and the directress has him verify his choice by placing the 2 pieces side by side and by counting their sections. Such exercises may be repeated in great variety, and through them the child learns to assign a particular name to each one of the pieces in the long stair. We may now call them piece number 1, piece number 2, etc., and finally, for brevity, may speak of them in the lessons as 1, 2, 3, etc. The numbers as represented by the graphic signs. At this point, if the child already knows how to write, we may present the figures cut in sandpaper and mounted upon cards. In presenting these, the method is the same used in teaching the letters. This is 1, this is 2. Give me 1. Give me 2. What number is this? The child traces the number with his fingers as he did with the letters. Exercises with numbers. Association of the graphic sign with the quantity. I have designed 2 trays, each divided into 5 little compartments. At the back of each compartment may be placed a card bearing a figure. The figures in the first tray should be 0, 1, 2, 3, and 4, and in the second, 5, 6, 7, 8, 9. The exercise is obvious. It consists in placing within the compartments a number of objects corresponding to the figure indicated upon the card at the back of the compartment. We give the children various objects in order to vary the lesson, but chiefly make use of large wooden pegs so shaped that they will not roll off the desk. We place a number of these before the child, whose part is to arrange them in their places, one peg corresponding to the card marked 1, etc. When he has finished, he takes his tray to the directress, that she may verify his work. The lesson on 0. We wait until the child, pointing to the compartment containing the card marked 0, asks, "And what must I put in here?" We then reply, "Nothing. 0 is nothing." But often this is not enough. It is necessary to make the child feel what we mean by nothing. To this end we make use of little games which vastly entertain the children. I stand among them, and turning to one of them, who has already used this material, I say, "Come, dear, come to me 0 times." The child almost always comes to me, and then runs back to his place. "But, my boy, you came 1 time, and I told you to come 0 times." Then he begins to wonder, "But what must I do then?" "Nothing. 0 is nothing." "But how shall I do nothing?" Don't do anything. You must sit still. You must not come at all, not any times. 0 times, no times at all." I repeat these exercises until the children understand, and they are then immensely amused at remaining quiet when I call to them to come to me 0 times, or to throw me 0 kisses. They themselves often cry out, "0 is nothing! 0 is nothing!" Exercises for the memory of numbers. When the children recognize the written figure, and when this figure signifies to them the numerical value, I give them the following exercise. I cut the figures from old calendars and mount them upon slips of paper, which are then folded and dropped into a box. The children draw out the slips, carry them still folded to their seats, where they look at them and refold them, conserving the secret. Then, one by one, or in groups, these children, who are naturally the oldest ones in the class, go to the large table of the directress, where groups of various small objects have been placed. Each one selects the quantity of objects corresponding to the number he has drawn. The number, meanwhile, has been left at the child's place, a slip of paper mysteriously folded. The child, therefore, must remember his number, not only during the movements which he makes in coming and going, but while he collects his pieces, counting them one by one. The directress may here make interesting individual observations upon the number memory. When the child has gathered up his objects, he arranges them upon his own table in columns of 2, and if the number is uneven, he places the odd piece at the bottom and between the last two objects. The arrangement of the pieces is therefore as follows: the crosses represent the objects, while the circle stands for the folded slip containing the figure. Having arranged his objects, the child awaits the verification. The directress comes, opens the slip, reads the number, and counts the pieces. When we first played this game, it often happened that the children took more objects than were called for upon the card, and this was not always because they did not remember the number, but arose from a mania for having the greatest number of objects. A little of that instinctive greediness, which is common to primitive and uncultured man. The directress seeks to explain to the children that it is useless to have all those things upon the desk, and that the point of the game lies in taking the exact number of objects called for. Little by little they enter into this idea, but not so easily as one might suppose. It is a real effort of self-denial, which holds the child within the set limit, and makes him take, for example, only 2 of the objects placed at his disposal, while he sees others taking more. I therefore consider this game more an exercise of will power than of numeration. The child, who has the 0, should not move from his place when he sees all his companions rising and taking freely of the objects which are inaccessible to him. Many times 0 falls to the lot of a child who knows how to count perfectly, and who would experience great pleasure in accumulating and arranging a fine group of objects in the proper order upon his table, and in awaiting with security the teacher's verification. It is most interesting to study the expressions upon the faces of those who possess 0. The individual differences which result are almost a revelation of the character of each one. Some remain impassive, assuming a bold front in order to hide the pain of the disappointment. Others show this disappointment by involuntary gestures. Still others cannot hide the smile which is called forth by the singular situation in which they find themselves, and which will make their friends curious. There are little ones who follow every movement of their companions with a look of desire, almost of envy, while others show instant acceptance of the situation. No less interesting are the expressions with which they confess to the holding of the 0, when asked during the verification, "And you haven't taken anything?" "I have 0. It is 0." These are the usual words, but the expressive face, the tone of the voice, show widely varying sentiments. Rare indeed are those who seem to give with pleasure the explanation of an extraordinary fact. The greater number either look unhappy or merely resigned. We therefore give lessons upon the meaning of the game, saying, "It is hard to keep the 0 secret. Hold the paper tightly and don't let it slip away. It is the most difficult of all." Indeed, after a while, the very difficulty of remaining quiet appeals to the children, and when they open the slip marked 0, it can be seen that they are content to keep the secret. Addition and subtraction from 1 to 20, multiplication and division. The didactic material which we use for the teaching of the first arithmetical operations is the same already used for numeration. That is, the rods graduated as to length, which, arranged on the scale of the meter, contain the first idea of the decimal system. The rods, as I have said, have come to be called by the numbers which they represent, 1, 2, 3, etc. They are arranged in order of length, which is also in order of numeration. The first exercise consists in trying to put the shorter pieces together in such a way as to form tens. The most simple way of doing this is to take successively the shortest rods, from 1 up, and place them at the end of the corresponding long rods, from 10 down. This may be accompanied by the commands, "Take 1 and add it to 9." Take 2 and add it to 8. Take 3 and add it to 7. Take 4 and add it to 6. In this way we make 4 rods equal to 10. There remains the 5, but turning this upon its head in the long sense, it passes from one end of the 10 to the other, and thus makes clear the fact that 2 times 5 makes 10. These exercises are repeated, and little by little the child is taught the more technical language. 9 plus 1 equals 10. 8 plus 2 equals 10. 7 plus 3 equals 10. 6 plus 4 equals 10. And for the 5, which remains, 2 times 5 equals 10. At last, if he can write, we teach the signs plus and equal and times. Then this is what we see in the neat notebooks of our little ones. 9 plus 1 equals 10. 8 plus 2 equals 5. 5 times 2 equals 10. 7 plus 3 equals 10. 6 plus 4 equals 10. When this is well learned and has been put upon the paper with great pleasure by the children, we call their attention to the work which is done when the pieces grouped together to form tens are taken apart and put back in their original positions. From the 10 last formed we take away 4, and 6 remains. From the next we take away 3, and 7 remains. From the next 2, and 8 remains. From the last we take away 1, and 9 remains. Speaking of this properly, we say 10 less 4 equals 6. 10 less 3 equals 7. 10 less 2 equals 8. 10 less 1 equals 9. In regard to the remaining 5, it is the half of 10, and by cutting the long rod in two, that is, dividing 10 by 2, we would have 5. 10 divided by 2 equals 5. The written record of all this reads, 10 minus 4 equals 6. 10 minus 3 equals 7. 10 divided by 2 equals 5. 10 minus 2 equals 8. 10 minus 1 equals 9. Once the children have mastered this exercise, they multiply it spontaneously. Can we make 3 in 2 ways? We place the 1 after the 2, and then write, in order that we may remember what we have done, 2 plus 1 equals 3. Can we make 2 rods equal to number 4? 3 plus 1 equals 4, and 4 minus 3 equals 1. 4 minus 1 equals 3. Rod number 2, in its relation to rod number 4, is treated as was 5 in relation to 10. That is, we turn it over, and show that it is contained in 4 exactly 2 times. 4 divided by 2 equals 2. 2 times 2 equals 4. Another problem. Let us see with how many rods we can play this same game. We can do it with 3 and 6, and with 4 and 8. That is, 2 times 2 equals 4, 3 times 2 equals 6, 4 times 2 equals 8, 5 times 2 equals 10. 10 divided by 2 equals 5, 8 divided by 2 equals 4, 6 divided by 2 equals 3, 4 divided by 2 equals 2. At this point, we find that the cubes with which we played the number memory games are of help. From this arrangement one sees at once which are the numbers which can be divided by 2, all those which have not an odd cube at the bottom. These are the even numbers, because they can be arranged in pairs, 2 by 2, and the division by 2 is easy, all that is necessary being to separate the 2 lines of 2's that stand one under the other. Counting the cubes of each file, we have the quotient. To recompose the primitive number, we need only reassemble the 2 files thus: 2 times 3 equals 6. All this is not difficult for children of 5 years. The repetition soon becomes monotonous, but the exercises may be most easily changed. Taking again the set of long rods, and instead of placing rod number 1 after 9, place it after 10. In the same way, place 2 after 9, and 3 after 8. In this way we make rods of a greater length than 10, lengths which we must learn to name 11, 12, 13, etc., as far as 20. The little cubes, too, may be used to fix these higher numbers. Having learned the operations through 10, we proceed with no difficulty to 20. The one difficulty lies in the decimal numbers, which require certain lessons. Lessons on decimals, arithmetical calculations beyond 10. The necessary didactic material consists of a number of square cards, upon which the figure 10 is printed in large type, and of other rectangular cards, half the size of the square, and containing the single numbers from 1 to 9. We place the numbers in a line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then, having no more numbers, we must begin over again, and take the 1 again. This 1 is like that section in the set of rods, which, in rod number 10, extends beyond 9. Counting along the stair as far as 9, there remains this one section which, as there are no more numbers, we again designate as 1. But this is a higher 1 than the first, and to distinguish it from the first, we put near it a 0, a sign which means nothing. Here, then, is 10. Covering the 0 with the separate rectangular number cards in the order of their succession, we see formed 11, 12, 13, 14, 15, 16, 17, 18, 19. These numbers are composed by adding to rod number 10, first rod number 1, then 2, then 3, etc., until we finally add rod number 9 to rod number 10, thus obtaining a very long rod, which, when its alternating red and blue sections are counted, gives us 19. The directress may then show to the child the cards, giving the number 16, and he may place rod 6 after rod 10. She then takes away the card bearing 6, and places over the 0 the card bearing the figure 8, whereupon the child takes away rod 6, and replaces it with rod 8, thus making 18. Each of these acts may be recorded thus: 10 plus 6 equals 16, 10 plus 18 equals 18, etc. We proceed in the same way to subtraction. When the number itself begins to have a clear meaning to the child, the combinations are made upon one long card, arranging the rectangular cards bearing the 9 figures upon the 2 columns of numbers shown in the figures A and B. Upon the card A, we superimpose upon the 0 of the second 10 the rectangular card bearing the 1, and under this the one bearing 2, etc. Thus, while the 1 of the 10 remains the same, the numbers to the right proceed from 0 to 9 thus. In card B, the applications are more complex. The cards are superimposed in numerical progression by tens. Almost all our children count to 100, a number which is given to them in response to the curiosity they showed in regard to learning it. I do not believe that this phase of the teaching needs further illustrations. Each teacher may multiply the practical exercises and the arithmetical operations, using simple objects which the children can readily handle and divide. End of Chapter 19. Teaching of Numeration. Introduction to Arithmetic. Recording by Melissa.